We're going to talk today about composition of functions, but before we really get into how to create composite functions, we're going to first talk about how I combine functions using algebraic expressions. So, now, can I add two functions together? Can we subtract two functions? That's where our focus is going to lie at the moment. So as we get started, I want to point out something from the lesson that we had and the notes that we have. When we talk about algebraic functions, all right, we can go through and say, all right, so for function f and g, those are the functions. The domains are a and b. So a is associated with f and b is associated with g. Let the functions f plus g, f minus g, f times g, and f divided by g, these are all defined here. All right, so the key is really, I want us to take a look at these here with the domains. We'll go through and we'll talk about this and how we go through and do the calculations for that in the next couple of slides. But looking at what we have here, I want to just make sure we understand these parts. So if A is the domain from function f and B is the domain from function g, all we do for all of these is we go through and we just combine the two domains. So if this is the set of all real numbers, A, and this is the set of all integers, which we actually label as Z, then the integers combined with the real numbers would give us a domain that would turn into, and again, it's that and this set, it would be all real numbers again. Okay, so all we're going to do is we're going to combine the domains. The only part that's different is when we're down here, because I also have to pay attention to make sure that, yes, it's the combination, all of the elements out of A and B, but the difference is that I have to make sure I do not include what is actually in the denominator that would make the denominator 0. So we know that already. I can't take this pen and turn it into absolutely no parts. It just can't be done. So we don't do that when we deal with the mathematics either. So for this particular example, all we're going to do is take the parts and add them together for the first one here. So then when adding this, I have 1 divided by x minus 2 plus the square root of x. All right, this is not something that we really want to worry or focus our attention on, making sure we have common denominators and then going through and combining the fractions. So we're not even going to worry about that here at the moment. What I want to figure out now is what is the domain, okay? So for part A, the domain would be all real numbers except 2. All right, so we'll say for function f, all right, and I'll put a little f down here, so that way we know domain with respect to function f. That for this, it would be the set of all x such that it does not include 2. So let's just go ahead and put it in this form for the moment, all right, such that x cannot be 2. The domain with respect to function g, in this case, well, I can't be anything that would make the radicand negative. So the thing underneath the square root symbol cannot be negative. So therefore, in this case, it'd be the set of all x such that x is greater than 0. And, taking a look back, can it be equal to 0? So the square root of 0, is that allowed? Yes, it is. All right, so it's going to be all of the values when I go through and take the intersection of both of these. So I have to look. So this says it can be everything greater than 0. This one says, however, it can't be 2. So when I combine the two sets together, I have to take the intersection of the two groups. So in other words, if I follow just this one and I put negative 2 in, so yes, here that's fine. I would have negative 1/4. But then if I put a negative 2 in here, I can't do the rest of this function. So all of these values in this domain are not going to be used, but all of the values in this domain would be used. So when we look at the domain of f plus g, we end up with the set of all x such that x is greater than or equal to 0, but x cannot be 2. So that's in set builder notation. Now if I want to go through and write that in interval notation, I come back here. All right, we started with 0. 0 is allowed here, 0 is allowed here, so then that means I need a bracket, 0. And I'm going to go up to 2, but I can't be 2 because if I am 2, then I have a problem here. So close this parentheses. And I'm going to union that set with from 2. Well, it just says it can be greater than 0, so I'm going to go all the way to infinity. All right. Now let's take a look at this again. Now in this case, again, I'm not going to go through and deal with trying to combine these things. I'm just going to go through and do the operations of it so that we can take a look at each of these individually. So again, up here, the domain of f is still the same thing. The domain of g is still the same thing. So now when we look at, oops, I made an error here. You notice I'm sitting here talking about the fact that this has got to be negative and I'm subtracting, and here I am putting the wrong value in here. This is why it's very good to double check everything as you go through. You get caught up looking at the problem above you and you go through and you make a small error. Now, if we go back to this page right here, we know that by going here that this, and this, they're all going to have the same domain. So let's go back to our problem. The domain of f plus g is right here. This is going to be the same as the domain of f minus g. Now I'm going to multiply, because I'm going to come down to this one. So I'm going to have 1 over x minus 2, and I'm going to multiply that by just the square root of x. So when we go through and we multiply it, this is the same thing as if it was over 1. You don't ever write it because it's not really necessary, but I'm going to take 1 times the square root of x, so I get square root of x in the numerator. I'm going to take my x minus 2, and I'm going to multiply that by the 1, and now I'm done. So that is the function f times g, which is right here. And again, we know, based on going back to this page here, that the domain is the combination for each of these. Okay, so it's just a and b. So what do they have in common? All right. So coming back here, that means this domain again that we've already used 2 times already is still the domain for what we're trying to do. Straight lines, not too great today. Okay, so now let's go back to this last one here on the bottom. All right, I'm going to extend the page so I've got plenty of room to go ahead and write this out. Okay, so I'm going to divide. I got to pay attention to what the different values were. So my square root is on the denominator. All right, so I've got then in this case 1 divided by x minus 2, all of which is divided by the square root of x. All right, so division is the same as multiplying by the reciprocal. So 1 over x minus 2, I'll just extend this line a little bit, times 1 divided by square root of x. Ugh. This looks fun. All right, it is what it is. So now when I go through and combine this, and I multiply it out, I get the square root of x times x minus 2. I'm not going to go through and deal with multiplying this back out because I still have to look to see what's going to make the denominator 0. All right, so remember, again, I'm going to go right back to where we were when we started all this. It's still the same domain that we looked at before, but the difference is I have to pay attention to when g of x is going to be 0. All right, so let's go back to the problem we were doing. Oops, too far. Go back to the problem we were doing. Okay. Back to extending my page again, and here we go. Now, so g of x, so remember this is g of x, so what's going to make that 0? So that means that I have to add to what we had before, that x is not allowed to be 0. So if I go back up to where I was before, I said, all right, it can include 0, but it can't include 2, can't include 2 again, and it can go all the way up to infinity. So the difference is here. Now that I look down here where x can't be 0, that means I have to change this from a bracket to a parenthesis. All right, or a paren. All right, so now my domain, let's get my writing utensil here, the domain of f divided by g is going to be then, all right, I'm at 0, but I'm not allowed to be because then that makes the denominator 0. I go as far as 2, union that with 2, and I'll go as far as infinity. All right, so I want you to pay attention to the difference in the two function domains. Well, actually, we've got 4 of them here, but the first 3 are all going to have the exact same domain. And we knew that again from the definitions that we had dealing with the domains. The last one, though, I have to pay particular attention to the fact that if I have a 0 here, I'm in trouble. So that's our example dealing with just the combination of functions using different operations. Hopefully this was helpful. Again, Robert Main, have a good afternoon, and see you next time.